We're studying IGCSE chemistry and we're revising chapter 15, reactivity of metals. All right, division 1. Now, Rania, start reading from here. Key properties. Or before you do that, start reading from here.
Yes, sir.
Reactivity series. From here.
Reactivity series, a ranking of metal based on their strength of reactivity.
All right, so ranking of metals based on their strength of reactivity. Now, what is the meaning of reactivity? What is this thing, right? Reactivity. Now, reactivity is basically how easily a metal reacts. Well, that makes sense, all right? Or not a metal or any element reacts, fine. But that's not what it means actually. That's just the surface level. The next thing is how easily a metal loses electrons and how easily a non-metal gains electrons. Now, why am I talking in terms of gaining and losing electrons? Because this chapter is all about redox.
Redox reactions.
Redox reactions. Now, we'll see what these are in a second. But just to know, reactivity basically means how easily something reacts. Okay?
Sir, isn't redox reaction when a chemical gain or lose electrons or be oxidized?
Yes, exactly. We'll get to that in a second, right? Before we do that, let's look at the reactivity series. Okay, now this right here is your big reactivity series. Now, one way I memorize this is kind of strange. I haven't seen anyone else do it. Is by just looking at the first letters. So kan, kama, zaf, saf, kab. That's like memorizing the whole reactivity series. Potassium for K. So potassium, sodium, calcium, magnesium, aluminium. Then you have zinc. Then you have iron, tin, lead, copper, silver, gold, platinum. One thing we realize from this is that we can divide these into a few groups. All right, I can make this group right here. Then I can make this group right here. Then I can make a few groups like this. Well, let's make groups like this. So the middle group, the top group, and the bottom group. So when we go from top to bottom, what happens is the reactivity decreases, or downwards, reactivity decreases. So the element at the top, the higher you are in the series, the more reactive you are. Exactly. Let's go. Now let's see how can we use this, right? One thing we need to realize is copper, silver, gold, or silver, gold, platinum, these four are the least reactive. They don't react at all, very less. While potassium, sodium, all of these react a lot. Now I want you to read from, just a second, not from there. Fine, all right. Read from here. Jawan, read from here.
The key properties.
Yes, from the first one.
Okay, the more reactive element displaces the less reactive one.
The less reactive one. Rania, next one.
Metals above hydrogen displace hydrogen from its acids, and hydrogen cannot reduce their oxides.
Oxides. Now, what this basically means is, look, metals above hydrogen displace hydrogen from its acids. What this really means is we're seeing a word called displace, okay? And that is a hint towards something called a displacement reaction. So we'll go there in a second again. What I want you to do right now is quickly write the key properties of reactivity series in your notebook. Tell me when you're done writing.
Sir, so all the elements above hydrogen, like from potassium till PV, it's gonna displace hydrogen.
Yes, it's going to displace hydrogen. Now, one thing we do know from the first point is whatever is more reactive, let's say, will always displace the less reactive. Now,
Yes.
okay, let's take two of these. If I take calcium and I take iron, can someone tell me which is more reactive?
What, sir? Calcium and what?
Calcium and iron, 1 and 2.
Calcium.
Calcium is more reactive. So what is going to displace what? Will calcium displace iron or will iron displace calcium?
Calcium will displace
Calcium will
iron.
displace iron.
Exactly. So more reactive displaces less reactive. And what that means is iron cannot displace calcium. Is that clear? Only calcium can displace iron. Fine. Now let's go back to the points here. Quickly write these down. Tell me when you're done writing. Or right now, just take a screenshot of this. Don't write this. Take a
Okay.
screenshot. Tell me when you're done.
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 Done. All right. Now, usually I would ask you to write this because these are important, but we don't really have time. Now, reaction of metals with water. Before we look at that, I'll like to show you the periodic table. Periodic table. All right. Now, if you look at the periodic table right here, group 1 is called alkali metal. This is alkali metal, all of this. Alkali metal. Then we have something called earth metal. Then all of these right here are called transition metals. And all of these, most of these, are non-metal. Except aluminium, of course, except all of these. Let's say most of these, like aluminium, gallium, these are metals. Except everything from group 14 is non-metal. Fine. So that's what we have here. Alkali metal, earth metal, transition metal, non-metals. The more right you go on the periodic table, non-metallic nature increases. Non-metallic nature. This chapter, previous chapters, but you need to know this. Nature increases.
What, sir?
Let's go from left to right. Let's say from left to right, non-metallic nature
Decreases.
increases.
Left to right.
Yes. No, it becomes more non-metal, right? You have alkali metal, then on the right side you have
Yeah.
non-metal. So the
Yes,
more
sir.
you go there, the more non-metal it becomes.
Yes,
Any
sir.
questions?
No.
Fine. Now what we realize then is, fine, we have these. Now another thing is, alkali metals are most reactive. So when you go from left to right, that means non-metallic nature is increasing. So the metals are becoming less reactive. What you'll realize is alkali metals are very reactive, then earth metal less reactive, transition metal even less reactive, non-metals are completely not metal, obviously. Now let's go to here, and I want you to write this in your notebook. Quick. Reactions of metals. Reactions of metal, that's the title. For today's date and date, class name, then start with this. Reaction of metals, alkali metals, which are called group 1. Plus water. That's the first thing we're looking at. Alkali metal plus water. What happens in everything? So start. Rania, read this one.
Property reactivity increased down the group.
So reactivity in group 1
Yeah.
increases down the group. So the more down you go in the group, the more reactive it becomes. Right? So lithium, potassium, sodium. That's what happens. Now quickly write the whole thing down, especially the key observations. Effervescence, fizzing, bubbles, floats, solid disappears, heat release, since action is exothermic. One thing we need to know is when you add alkali metal to water, the reaction is always exothermic. Jawan, do you know what exothermic means?
Yeah.
What is it? Tell me.
Heat is given out.
Heat is given out. Okay. So if let's say you have a beaker like this, and in this beaker you have sodium metal, and I put some water in it. Now heat is given out. Okay. If I touch the beaker, will the beaker feel hot or cold?
Hot.
Javan. Okay. Rania chooses hot. Rania can think one more time. Javan, what do you say?
Water with what?
If you
Sodium.
have a reaction, exothermic reaction, okay, happening in this beaker, and if you
Okay.
touch the beaker, will you feel the beaker is cold or hot?
I think hot. Cold.
Cold. Rania,
Yeah.
why do you think it's going to be hot?
Sir, because we said it's exothermic reaction, so it's giving out heat.
It's giving out heat. So what we need to realize is giving out heat to the surrounding. That means you're going to feel that heat, right? When the heat is given out, you'll feel the heat, and that's why it's going to be cold. It's going to be hot, sorry. Let's write it down here. Delta H. When the delta H value is negative, that means it's going to be exothermic and which feels hot. Well, let's just say exothermic, heat given out or heat released, which is basically feels hot. Now the opposite happens for endothermic. When you have delta H, which is positive always for endothermic reactions, heat is taken in. Now since heat is taken in, it's absorbing the heat so that you cannot feel the heat.
Sir,
Heat is
I
going
have
away.
a question.
Ask me.
Can a reaction be both exo and endothermic at the same
No,
time?
that's not possible. Right?
Sir, okay, for example, if we were having boiling water and we
Yes.
added some ice cubes to it,
Yes.
will that be exothermic or endothermic?
That's not a chemical reaction. A chemical reaction happens when you join two elements and you get a new product. That the thing you're describing is melting. That's a state change. Ice is turning into water. Now, I'll tell you what it is. I'll tell you what it is. So boiling, okay, is endothermic, and melting is exothermic. No. It's the opposite. Condensation is exothermic. Fine. So boiling, melting, boiling is endothermic. Freezing.
Sir, isn't it exothermic?
What is exothermic?
Melting and boiling.
Now just give me 1 second. This is the correct answer, but let me check once, and I'll get back to you. I want you to
Sure,
write this
because
first. This is chapter
it's-
15.
Okay.
Yes, all right. Boiling is endothermic because to boil water you have to provide heat. Boiling does not happen on its own, right? While freezing condensation is exothermic. You don't have to give heat, right? So if there's any reaction which you need to give heat, therefore that reaction will be endothermic, because if you don't heat it, it will not happen. But exothermic reactions happen on their own. You can also write this down to memorize it. This will be asked in the MCQ. At least 2 questions on this. MCQ. Why? We'll look at that later. We're not doing energetics right now. So let's focus on this.
Okay, sir.
You can still ask me doubts if you have for any topic actually. But first, write this down. Now there are a few key reactions we need to know. Reaction of metal with water, reaction with air, and there's also reaction with acid and bases and all of that, but that's an acid-base chapter. In this chapter, all you need to know is how do alkali metals react with water and how do they react with oxygen.
Okay, sir.
Now finish writing quick. By the way, this point about here, over here about alkali metals being stored in oil. That is a very important thing right here, this one, which will be asked in ATP and in MCQ. They always ask this. I remember when I did past papers, I did all the past papers from 2003 till 2017, and this question was always there. Why do we store alkali metals in oil? The answer for that question is because they react with air and they form oxide. So we don't want that happening, therefore we must store it in oil. Javan, any questions?
No.
Now can you hear the video?
Metal surface. Here, for example, is lithium. When we slice it, you can see the metallic luster, but the black coating quickly reappears.
Now can you hear it?
Yes.
All right. Now what's happening is when you cut it, obviously, it's very shiny. With a knife, you cut it, it's shiny. But after some time, it becomes black. Why does that happen? Because it easily reacts with air. That is why we must store it in oil. Must store it in oil. So look at this. You see how that black layer from that layer is oxide. Okay, which would be in this case, since this is lithium, it would be lithium oxide because it reacts with oxygen in the air.
Again, when we cut it, the metal surface can be seen. But this time, corrosion occurs even more quickly. With the next alkali metal, potassium, the corrosion in air is so quick that it's hard to see the metallic luster at all. As we go
Alright, so as you go down the
group, the elements seem to react more quickly with air.
reactivity increases. Now,
we'll start with lithium. The metal floats on the water and reacts with it, giving off hydrogen gas. Now for sodium. The same sort of thing happens, although the reaction is a bit more vigorous. All the alkali metals react with water in the same way. Let's see an equation for the reaction.
Alright, now right here, you get the metal plus water, it forms, it is going to release hydrogen gas and makes an alkali, right? NaOH is the alkali formed. You have the equation already written in your notebook. It was on the whiteboard. Now you may realize a few things are happening. The first thing is it's floating. That was one of the key observations I gave you. Another thing is you can see effervescence. Effervescence basically means fizzing or bubbles. So fizzing is obviously there and bubbles are also there. So that is what you'll write in the exam if they ask you what are the observations if we react an alkali metal with water. Yes.
It will have hydrogen gas and hydroxide.
Not in hydroxide. Hydrogen gas is released outside as bubbles. Right?
What about OH?
OH is bonded with the Na. It's together with Na. NaOH.
NaOH.
That's sodium hydroxide. Sodium hydroxide. Yes, that is how it forms.
Yeah.
Okay. Now, with a single positive charge.
Now look at this.
Now for potassium. This time you'll see a flame. The heat given out by the reaction is produced so quickly that the hydrogen gas catches fire. It burns with a lilac flame.
Now, okay, the color of the flame, that's again alternative practical, but we don't do it right now. You would realize that this is not steady. Lithium was steadily reacting, but potassium is violent. All right.
The next element is rubidium. This time, we put a safety screen between us and the reaction. You can see that things gradually become more terrifying as we go down the group. Let's try cesium, our fifth alkali metal.
Right. That is how reactive metals are, and that is why we must keep them in oil. I hope that's clear. Now, key observations: they float, solid disappears, effervescence. Any questions, Rania, Javan?
No, sir.
Now over here, you'll realize that you have 2M plus H2, it gives us 2MOH
Sorry,
plus
sir,
H2 gas.
Are these reaction all of them exothermic?
Yeah, all of them are exothermic. Metal plus water is always exothermic. That is why you can see all the heat and the flame. All of that is exothermic. Then reactivity of metals. That's done. Let's go to, well, endothermic, exothermic. We have done that. Next thing is reaction of earth metals. Now we have done alkali metal. That's group 1. Earth metals are group 2. They're usually found in earth. That's why we call them earth metals. Group 2 reaction of water, and but the problem is group 2 doesn't really react with water easily, because as you realize, down the reactivity series, the reactivity decreases. So magnesium is not as reactive as sodium, potassium. All group 2 are less reactive than group 1. So they do react, some of them react with water, but it's very slow. But if you add hot water, heat, or steam, then the reaction is very strong. So quickly, finish writing this part. The one in the blue box. Tell me when you're done writing. Finished?
No,
Javan, how much have you written?
I'm writing the red part.
All right. That's the main part. The general equation. All you have to do is replace the M with any group 2 metal. So you can write, in place of M, you can write calcium, magnesium, barium, your choice. Now these are the easy reactions. The main reactions are displacement reactions.
Then, sir.
Finish, then write this part.
Which one?
This one, reaction of group 2 with steam. The general equation and the reaction with steam. Rania, do you have any other test tomorrow?
No, sir.
And any this week or next week?
Math.
Any other test? Math. Which chapter?
I'm not sure actually. Joanne, which chapter do you have?
Similarity and let me check.
Angle properties.
Yes.
All right. Now we finished those chapters. I'll have to revise it for the other students. All right, no worries. When is the test?
Tuesday.
Tuesday.
But I might ask her to take it on Wednesday because I might not be in school on Tuesday.
All right. Hopefully she will consider it. No worries.
Mm-hmm.
Now the equations which I've given you.
Group 1, right?
Yes, Rania, tell me.
Sir, calcium isn't it group 1?
No, it is in group 2.
Okay.
Calcium, magnesium,
what's
barium,
M?
strontium. M is any variable. All you have to do is replace M with calcium, Ca. So if they ask you what is calcium with cold water, in place of M, you'll write Ca. Or if they ask you what is magnesium with cold water, you just write Mg in place of M. So the equations are same, you just need to memorize it.
They form metal oxide plus hydrogen.
With steam, yes, they form metal oxide plus hydrogen gas.
Hydrogen gas.
The hydrogen gas is a common thing with water, but the difference is with cold water you get a hydroxide, but with steam you get an oxide. The equation is a bit different, you'll see, right?
The answer.
Finished. Jawan, how much have you written?
I finished.
Finished. Good. Now these equations are not given in Z notes. They are given, but not in IGCSE. They're given in A levels. So that's the difference. I'm making you write this because it's going to be easy for you. We'll practice question later. The next thing is a reaction of metal with acid. Now write this as well. Tell me when you're done. What are metals? Metals are group 1 is sodium, group 2 is magnesium. A transition metal perhaps is iron. Types of acids are hydrochloric acid, sulfuric acid, phosphoric acid. These are 3 kinds of acids. Now more on this in the chapter for acids and bases. Now, Rania, have you finished acids and bases?
In school?
Yes.
Yes, sir.
Right. Jawan, you must have as well, right?
Yeah,
Yes.
we are in the same class.
Same class. All right. Good.
Obviously.
So can you tell me what is the meaning of diprotic acid?
Diprotic acid.
Diprotic acid, yes.
Actually, I don't know. Honestly.
Jawan?
I'm not sure.
All right. Then you guys have not really learned acids and bases. Never mind. Now, finish writing this quickly. think the issue would be your school tries to finish the syllabus. I try to make sure you guys understand. So if you don't know what diacritic means, then the chapter is done in school, but you don't really know what it means. So that means you have to do it one more time.
Mm-hmm. Done, sir.
Finish, Javan.
Done.
So we'll look at how to do all of this in a second. How to use this information in questions. Now, quickly take a screenshot of this. I won't ask you to write this. You should write this, but we don't have time. Now, you need to memorize this table by heart, which is important because these kind of questions always come. It's not in your book, which you have right now. This book is a different one. The old book you had.
I have the old book also. Okay, done.
Now, screenshot taken.
Mm-hmm.
Yes.
Javan. All right, let's go down. The next thing is displacement reactions. Now look at this, what happens? What happens is, let's say I had copper sulfate solution, okay? Copper sulfate solution. Now copper is a metal, obviously, and it's not reactive, is it? It's in the bottom. If I write this for you, now this is the reactivity series. We have to use this to solve the questions.
Sir, how do
Right.
you remember it?
Well, I made it myself. All you have to look at is the first letter. So it's like a song for me, like kan kama zaf sap kab. It's kind of silly, but does the job. K and kan kama zaf sap kab. Right. Okay. Now you have to memorize this reactivity series, by the way. You should. It will not be given in the exam, so it's something you need to memorize. Ionic salt, copper sulfate. Now, what happens if I add a sodium in there? First, tell me what is more reactive, copper or sodium?
Sodium.
Sodium is more reactive. So, as we know, more reactive replaces or
Replace the less
displaces.
reactive. Mhm.
So, not really replace, but displaces the
Yeah,
less
displace
reactive.
the less reactive.
Now, okay, then what will happen? What happens is the reaction, then the solution then becomes Na2SO4 or sodium sulfate, that's copper solid. So what we get is from the solution, copper is displaced, or we can also say replaced, but don't write that in the exam. Copper is, let's say, replaced from the solution. So copper is left alone, and sodium takes the place of copper in the solution. So you'll see a few things happening. Color change happens. You'll see a solid may form, okay, like copper. Now, have you done precipitation reactions in school?
What reaction, sir?
Precipitation reaction. Precipitation.
Yes.
All right. What kind of reaction is that?
Sir, isn't it precipitation when we used for replacing or taking salt from a solution?
Okay, that's one thing. That's one thing. But precipitation is whenever a solid product forms in a reaction. Those reactions are precipitation. Now, let's just say, just give me 1 second. All right, back to class. Now you have copper sulfate aqueous plus sodium solid. When they react, sodium is going to replace this guy, and in place of that, we'll have Na. Now, one thing that's important is we need to make sure the charges are correct. Since SO4 is 2 minus, which you need to memorize again, and Na is plus. So crisscross from chapter 3, you get that 2 will come here.
SO4, Na2,
Na2,
SO4.
4.
Mm-hmm.
The 1 will come over here. You don't have to write it. Now, copper is left outside. Now, please write this in your notebook. Tell me when you're done. This part. Write the example as well.
Sir, about hydrogen and, for example, chlorine, also like iodine, they exist in a diatomic form, right? They are diatomic molecules.
Yes.
So when we write them, we should write it as I2 or H2
Yes, always.
in an equation.
Yes. Cl2, Br2, I2, H2. Well, not He2, that's wrong. Because that it's group 8. Group 8 is always single. It's monatomic. While everything in group 7 is diatomic, diatomic, as well as O2, right? All of these.
Okay.
Sulfur is S8. We look at that in chapter for sulfur inorganic, which is like, let's say, chapter number 24 or something. So forget about that.
Done, sir.
Finish this. Done. Next thing. Javan, finished?
Yes.
Now look at another reaction. Can someone tell me what is more reactive, zinc or copper?
Zinc.
Zinc is more reactive, so it will replace copper sulfate. It won't replace copper sulfate, it will replace copper. So one thing is, they'll ask in the exam, is the color change happening? Zinc is gray,
The observation.
but copper is red-brown. So when you react these guys, what you'll see is that the blue color will change to gray, or the solution will change, and you'll see a copper solid forming, or some red-brown solid forming in the bottom of the beaker. That is one observation, because since copper is being thrown out from the solution, it's being replaced and thrown out. So you'll see that copper forms. Okay, so that's red-brown. Now go on. Now we are at redox. We are at redox. Fine. Now please write this in your notebook and tell me when you're done. First, Javan, start reading from here.
Reduction is loss of oxygen. And gain
Alright,
of
stop.
electrons.
Rania, read the next thing for oxidation.
Oxidation is gain of oxygen and loss of electrons.
Electron. So what we realize is, well, one the opposite of other, and reduction is loss of oxygen, gain of electron. There's one short form just like for the reactivity series, which is oil ring. Oxidation is loss of electron, and reduction is gain of electron. But I would prefer you use this. This is not something I prefer. It is going to confuse you. So please just remember this. Reduction is loss of oxygen. Well, reduce means reduce, loss. But it's opposite of the term for oxygen. Fine. So reduction is gain of electron, while oxidation is loss of electron. Now, Rania, read the first one.
Reducing agent is compound oxidized.
So stop. Whatever is oxidized is called the reducing agent. Okay, it's like sacrificing itself. It's
Sir,
like, okay, I'm going to get oxidized.
Of like, isn't it its definition like the opposite of reduction and oxidation?
Okay, but what you need to realize is, if it's called reducing agent, then it is going to be oxidized.
Yeah.
So don't relate this with these definitions, but relate it with the word here, reduce. So reducing agent is being oxidized, oxidizing agent is being reduced. Now, how does that make sense? Well, it makes sense if you think about this. Agent is someone who helps, right? So if itself is being oxidized, it is helping the other guy be reduced. Okay, that is what it means. So if I am oxidized, then you are going to be reduced. So I'm helping you reduce yourself. Now, quickly write all of this in your notebook. Tell me when you're done. Javan, any questions?
No.
So can I ask you some questions? Well, keep writing.
What?
Should I ask you a question? All right, I'll ask you a question regarding this. Tell me, what is oxidizing agent?
It's when compound is reduced.
So it is the compound which is reduced. Now, oxidizing agent is a name for compounds. It's not a process. So we'll look at examples soon, but quickly write this and tell me when you're done.
Done, sir.
Everything?
Yep.
All right. That's quick. Javan, how much have you written?
I finished.
Next. All right. Now, displacement as redox reaction. There's a 3-step process here. Let's start with the first one. Read the equation. Zinc sulfate. Yeah. Okay. Yeah, go on. Zinc.
How is that zinc sulfate?
No, that's not zinc sulfate. That's zinc. Then we have copper sulfate.
Yeah,
right?
I thought I heard you saying zinc sulfate. Okay, zinc plus copper sulfate. Zinc will displace copper, and we will have zinc sulfate plus copper solid.
Now, the states are very important here. I've given you all the examples, and all of those equations have the state symbols. There are a few symbols, which is gas. Rania, tell another one.
Liquid, aqueous.
Javan, another one.
And solid.
Really? Okay, fine. Now, what happens after this? We realize that anything that is aqueous, is always dissolved in some water. It's actually ions. Okay, aqueous means ions. Therefore, if I have copper sulfate aqueous, it's actually copper 2 plus ion and SO4 2 minus ion. Dissolved.
Sir, but for example, how do I know if it's aqueous or solid? Sometimes like it's confusing.
It will be given in the question. Aqueous. Okay. And well, all salts usually they are going to be aqueous. When you're adding it to water, it has to be aqueous. Okay.
Yes, sir.
But if you take just a metal, it's always going to be solid. So metals are solid and solutions are aqueous. Now, when you separate this into copper and sulfate, what you get is two ions, and we do the same thing for zinc sulfate, zinc Zn2 plus and SO4 minus. Fine. Well, I can't divide copper because it itself is an atom. It's not an ion. It's not aqueous. The next thing is cancel out spectator ions. Please write the definition of spectator ions in your notebook.
Sir, can you explain number 2?
Yes, can you hear me?
Yes, sir.
Yes, all right. Number 2. First, write down what are spectator ions. This will be asked in the exam. What are spectator ions? Write it separately. And by the way, you can skip this part. Don't try that. Are common at both sides. That's for you to understand. But in the exam, you'll just write ions that are not taking part in the reaction.
Done.
Devan, finished?
Yes.
All right. Now you have zinc plus copper 2 plus. Can you tell me what is common on both sides? Which ions are common?
Sir, common in what way?
In what way? They're exactly the same. Well, you have Zn, but over here you have Zn2 plus. Well, that's not same. But look at Cu2 plus. Well,
Sulfate.
Cu2 plus and copper. But
That's
sulfate is
O4.
same. Look, SO4 minus. So let's just take those people, these guys, and we'll just cancel that out.
Oh, okay. I remember this. I studied it last year.
Now, next thing is cancel spectator ions done. To get what? Net ionic equation. So when you cancel out all the spectator ions, you get something called net ionic equation. You should, by the way, keep writing this from the beginning. Now, Zn solid, also pay attention to the choice on the whiteboard. Zn solid plus Cu2 plus aqueous is giving us Zn2 plus Cu solid. That's my net ionic equation. Okay. Now, our job is to find what is the oxidizing agent and what is the reducing agent. All right. How do we do that? Well, to do that, our job is to look at the ions, the charges. And we only compare the same elements, obviously, zinc and zinc. Over here, the charge of zinc is 0 because it's an atom. It has no charge. But here, if it becomes an ion, it's 2 plus.
2 plus.
Now, how can I go from 0, or let's say, how can I go from 0 to 2 plus? I have to gain what?
Oxygen.
What's happening? Now, well, oxygen is not really being gained. I'm gaining 2 positive charges. What am I gaining?
So I'm losing electrons.
Losing electrons. Okay, we'll get to that. So we're gaining 2 positive charges. From 0 to 2 plus, the charge is increasing by 2. Okay. So can I say?
So that's oxidation. So we're.
Yeah, that's oxidation. No, that's that is oxidation. Just a second, Rania. What's happening is if we increase the charge, now what that means is if I say gaining 2 positive charge, that is the same as losing 2 negative charge. Because look, if you remove negative things from your life will become positive, right? That's what's happening. If you remove 2 electrons, then the atom will become positive. In the same thing here, look at copper and 0. Copper and the copper atom, copper ion and copper atom. Now from here to here, what do I have to add to 2 to make it 0? What should I add to 2 to make it 0? 2 plus what makes 0?
2 minus 2.
2 minus. Well, if I add minus 2 to it, it will become 0. So now minus 2 is not something we can easily add. But what we can add easily is electrons. Now, from this net equation, we have to write something called the half equation. What is half equation? Well, all you have to do is write the 2 ions on each side. So let's take on the left side on the left and the right side on the right. Let's start with copper. So Cu2 plus on the left side and an arrow Cu0. Fine. But what change should I make to balance this equation? Well, since this is 2 plus, I just add 2 electrons for this to become Cu plus. And on the other side, all I have to do is remove 2 electrons from Z and 0 to make
Sir,
it.
I have a question.
Ask me.
Do we show gain of electrons before arrow or after?
Again, you can do both. Now, gain of
Sir,
electron
yeah,
is
we
always
can
before
do
arrow.
both, but sometimes the teacher she just say we should like show it as the books does.
Yes, we'll get to
I
that.
don't know which actually is before or after, but yeah.
Now it's like this. Now if I write Z2 plus minus 2 electrons, right? We go from 0 to 2 plus. Can I do this? Instead of writing minus 2 electron here, I'll move it. I'll shift this like algebra and maths to the other side, and it will become plus 2 electrons. Fine.
Yeah.
So that's how we usually write it, and that's how would I recommend you write it. But since we're just practicing things right now, we'll write it like this. All you need to know is zinc is losing electrons, so it is oxidation. It's oxidized, and copper is gaining electrons. It is. Tell me, what is gaining electrons?
Reduced.
Reduced. Now, next thing is, so if it is reduced, then what kind of agent is it? If copper is reduced, then it is
Oxidizing agent.
oxidizing agent. If Zn is oxidized, it is reducing agent. That finishes the whole redox part. Now, the next thing would be chapter 16, but I don't think we can do it right now. What we will do right now is we'll practice a lot of questions on this from the past year.
Okay.
Now, meanwhile, write the whole thing in your notebook. The whole thing from the beginning to oxidized right here. Well, I'm looking for the questions. Now take a screenshot. The question is ready. Tell me when you're done taking a screenshot.
Done.
Done. Rania,
Yes, sir.
screenshot taken.
Yep.
All right. Now this is actually 2 classes which I'm teaching in a single class. That's the fastest we can go actually. So I don't think we can cover extraction today, but stick around. I'll give you the notes for this. Take screenshots of them and memorize them. 16 is much easier than 15. All you have to do is memorize. Now let's look at a question. Is it blurry? Can you see it properly?
Yes, sir. That's clear.
So this part of the class is called skill check. We do this after every class we solve past papers after every class. Because why leave past papers until the end of October, November, December, when you can do it after every class? Now read. Rania, read the question.
Okay. Calcium reacts with nitrogen to form the ionic compound calcium nitride.
Skip that.
Draw a
Never
diagram.
Never mind. Stop. Read this question. Read this one. That is chapter 3.
Which
This
part?
is chapter 15. Part C.
The reaction between calcium and nitrogen to form calcium nitride is a redox reaction. In terms of electron transfer, explain why calcium is the reducing agent. Okay.
Okay, how does this work then? Well, what we realize is calcium is reacting with nitrogen. Okay, and it is making an ionic compound called Ca3N2. Okay, let's write that here. Calcium plus nitrogen makes Ca3N2. Now let's balance this. So there is 2 nitrogen here, so we must have 2 nitrogen here. 3 calcium here, so 3 calcium here. That's a balanced equation. Now this is the equation which they have given you. Okay, and how do we find the
Sir,
reducing
isn't
agent
it
and activation.
shouldn't we write it as N2?
Yeah, we should write it as N2. Yes. We should write it as N2. Now, next thing is, when you have this right here, our job is, since they're telling us that this is an ionic compound.
Mm-hmm.
Well, ionic, since it is ionic, this can be separated into ions. Let's do that. So first step, tell me the whole equation and
So it
separate
will be
these guys in ions.
Ca
From the beginning, 3Ca plus
N2,
N2,
then also Ca and then 2.
Ca then 2,
No, Ca3
Ca3,
plus N2.
N2. But that's what's happening though. What's happening is, since these are ions, okay,
So like, do we write it as Ca with the charge 0, and on the other
charge
side
2 plus.
C?
This is 0, okay, while this
Yeah.
is 3Ca 2 plus.
Mm-hmm.
And this will be N3 minus. Fine.
Okay.
That's what's happening. Now we never write 0. Okay, we don't do
Why?
that. Because, well, if there's no charge, we mean there's no charge, right? We don't have to show it. We can write 0. They won't mind. But since we already know there's no charge, therefore we automatically know it's going to be 0.
Okay.
Now, okay, let's compare. The next thing is remove any spectated ions. Now, for this question, I want what was the name? Javan to answer.
John.
Any spectated
What?
ions, Javan? Any spectated ions over here in step 1?
No.
No, because all of them are different. Second step
Yes.
is to compare each of these. So we'll compare calcium and calcium 2 plus from here to here. Okay. So can you tell me what is the change happening? On the left side we have calcium and it becomes calcium 2 plus. 3 calcium becomes calcium 3Ca2 plus. Okay. Now that's fine. But let's remove the 3 right now. We're just comparing calcium and calcium 2 plus. Did it lose electrons or did it gain electrons? Javan.
Lose.
Let's write it like this. Ca minus 2 electrons becomes 2 plus. Then Ca, the Ca is done. Then we have N. Okay. Now this, is it losing electrons or gaining electrons, Tanya?
Gaining.
How many?
3.
3. Okay, that's done. Fine. But one thing, I'll take this electron to the other side to make it look better.
I did that actually.
Get that? Good. Now this is what we have. Now please tell me, is what is being oxidized and what is being reduced?
Okay. Calcium is oxidized, while nitrogen is reduced.
Now Javan, tell me which is the oxidizing agent, which is the reducing agent.
Nitrogen is oxidizing and calcium is reducing.
Nitrogen is oxidizing agent and calcium is reducing agent. And we don't write it like this. I can write it just as, well, in the exam you have to write the full thing, but over here we'll just write Ra, reducing agent, and OA, oxidizing agent. Fine. So the question, let's read the question one more time, Javan. Read it.
The same question.
Yeah.
Same question, only the highlighted part, yellow.
In terms of electrons transfer, explain why calcium is the reducing agent.
So answer is 3 marks. So 3 marks in the exam will always mean 3 points. And 3 points mean you'll have exactly 1 minute and 30 seconds to answer this. Not 1 minute 30 seconds, sorry. No. You'll have, yes, 1 minute 30 seconds. So you have the time. Time starts now.
Sir, like, do we
Tell me
say
the answer.
that calcium is oxidized, so it's the reducing agent?
Yes. And how do you
Because
explain
it's gaining two
oxidation?
electrons.
Exact. No, it's not gaining 2 electrons, is it? Calcium.
Huh?
What is calcium doing? Is it gaining electron or losing electron?
Losing, I mean. Sorry.
So we have to write a few things, and we'll write it like this.
Hmm.
So we'll write it like this. First, the answer is going to be the format. Please write it over here. Y is, let's say, a compound or a compound reducing agent. Write it like a question answer.
Okay.
Now, we did this for all these chapters 14, 15, 16, like this. So I'll send you the recording if you want it. You can watch those. Because the method is important in the exam. Now we have
What's
compound
first
reducing.
point?
The first point is calcium
Mm-hmm.
loses electron. Before we write that, sorry, actually, calcium is oxidized. So it is reducing agent.
Sir, can we say calcium is oxidized by losing electrons? So it's the reducing agent.
Say that again.
Calcium is oxidized by losing electrons, so it's the reducing agent.
Well, you have to put the words in there in any format you like, right? So calcium is oxidized by losing electrons. So it is reducing agent. That's a good way to put it. Fine. But the mark scheme actually separates it. You're getting 2 points in the same die, but the mark scheme is actually doing this.
Okay.
Okay, these electrons which calcium is losing, what is gaining those electrons?
Sir, can you repeat, please?
The question is, look over here.
Mhm.
If calcium loses
Which
electrons,
are gained by nitrogen.
which are gained by nitrogen. So nitrogen, so electrons are basically shared between each other. If one person loses, the other must gain. If one gains, the other must lose.
Yes.
So therefore, which are gained by nitrogen. That's the answer, 3 marks. This was obvious, this was not obvious for you. If you don't write this part, you're losing marks. Gained by nitrogen, and let's say, which is oxidizing agent. Finish writing, tell me when you're done.
Done.
Read part D. Part D, this one. Out loud.
Who?
Jawan, read.
The oxidation states of vanadium in its compound are V plus 5 and V plus 4 and V plus 3 and V plus 2. The vanadium 3 ion can behave as a reductant or an oxidant.
Well, reductant is the same thing as reducing agent. Oxidant is the same thing as oxidizing agent. Perfect. Now they're asking us indicate on the following equation which reactant is the oxidant. Which reactant is the oxidizing agent? Quick. I need the answer in the chat. It's like a quiz. The person who gives the answer first gets the point. Should I help?
Okay, I was asking while I was muted. Sir, I was saying oxidant means oxidized.
Oxidizing agent.
Okay.
OA, oxidizing agent. That's what it is.
Zinc
Yeah.
is oxidant.
Zinc is oxidant. This one?
Yeah. Yeah.
All right. Rania, your answer?
Wait, sir.
Now I want you to solve the next question, Jawan.
Give me a second. Oh. It's not oxidant. It's the reducing agent, zinc.
Okay, before you correct the other person, give me your answer. So I'll see if it's your answer is correct or not. Quick.
Sir, what is V actually?
V is
Vanadium.
vanadium.
Vanadium. Okay, so it will be the oxidant.
Vanadium 3 plus or vanadium 2 plus?
3 plus.
3 plus. That's the correct answer. So we'll see what's happening first. Look, first thing first is check from here to here what change is happening. Okay, we'll see. Okay, so it's going from 3 plus to 2 plus. That's -1. From here to here, that's +2. Okay, so -1 and +2. Now, how can I write this as what is oxidation? Well, gain is oxidation. This is oxidation. So therefore, zinc must be Ra. A reducing agent because zinc is being oxidized, so it must be a reducing agent. Now, this is reduction. So this guy must be the oxidizing agent. Any questions?
Not for me.
Javan, any questions?
No.
Now, which change in the following equations is oxidation? Tell me.
Sir, shall I solve it too?
Yeah,
Iron.
obviously.
Iron is oxidant.
Iron. When they're not asking oxidant now, they're asking oxidation. Which change is oxidation? So
Vanadium.
vanadium. Vanadium to what? So I'll tell you how to write this. In this these questions, we answer it in this format. So we just write oxidation. Okay. Or we can write, well, I used to write it like this. I'll take what is oxidation first from here to here. That's +1. That's your first step in the exam. This is your habit. There should be a habit to do this. Now from here to here, that's -1. So I know what is oxidation reduction now. So Va 3 plus to Va 4 plus is oxidation. 2 marks done. That's it. So you get 2 marks. 1 mark for this person, 1 mark for this person. Done. Any questions?
No.
No, but we'll have to do a few displacement reactions. I'll give you one. Now let's try if you take Mg plus, let's take this one perhaps, Al2O3, or not even Al2O3, Fe2O3 plus CO gives us Fe plus CO2. Tell me which is the oxidizing agent, which is the reducing agent. Rania, can you draw on the screen?
Yes, sir.
So draw, make whatever you want to make. I showed you the method.
Okay, give me a second, sir. This will be. So, like, can I show it like KFA?
You can tell me I write for you as well.
Sir, will it like be Fe3 minus?
Fe3 minus where?
Sir,
Well,
the
the first
valency,
thing,
it will be 3. So I'm not sure
yeah,
if it's
3.
positive or negative. It will be
Metals are always positive.
positive. Yeah. So it will be
Yeah.
Fe3 plus.
Let's separate this first, right? So
Yeah.
step 1. So Fe3 plus, how many Fe3 plus? 2 plus,
Plus
let's say
O.
3O2.
Yes, sir.
Then,
And then an arrow. Oh, okay.
what about,
Plus CO. Plus CO, then an arrow.
okay. Then,
Sir, is this carbon monoxide?
yes.
Sir, what's the valency of carbon monoxide? Is it 3?
Now, the problem is, this is not an ionic compound, right? But we can write it like this. So carbon is always 4 plus, and oxygen is always 2 minus. Okay. We can't do it like that. Your job is just to look at CO. Okay. Because it's not an ionic compound, so you can't make ions with it. Like,
okay, then it will be Fe plus CO.
and anything missing?
Sir, wait. I can see
CO2.
the important. Okay.
Now, Javan, the next step.
The half equation.
Half equations, yes.
Okay. Fe
Fe
3 plus
3 plus
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 E minus
E minus
She means electron. Mhm.
3
then
gives us Fe.
yes. Fe. Perfect.
Sir,
Yeah.
we can show it on half equation. We can show it for 1 only, right?
No, you can do it for 2 as well.
Yeah,
but
I
the
mean,
best
like,
the
we
best
can.
habit is 1.
Yeah.
And you write it like this, times 2. If 2 is happening, then you write it like this. So
Okay.
twice of this is happening. And then you can write afterwards, later if they ask you. Sometimes they'll give you the half equation, you'll have to find the final equation. So you will have to multiply, you'll have to make E common. Okay, now next equation, Rania.
Okay. Sir, actually, I'm confused about this one. So can you explain it?
Confused about this one. All right.
Yeah.
So what's happening here is, especially we'll see
Sir,
in
like,
this case,
won't we
yeah,
cancel the CO from both sides?
that's carbon dioxide and that's carbon monoxide,
Uh-huh.
right? So what's happening is this is what's happening. CO plus 3O2 minus gives us CO2. Okay, but we have 3 of these. So what we'll have to do is, let's balance it. 3 of these. Yep, okay. We have 4 of these on this side. Now we have 4 of this on this side, right?
For
Now
what?
your job, you have
For
4
oxygen?
Yes.
Mm-mm.
4 oxygen
What
and
about
4 oxygen
carbon?
there. Carbon is 1, 1. Well, it's actually
Isn't
2.
it 2?
It is 2. So we'll balance that.
So we have 2 carbons. 2 carbons.
It's 2 carbons. We have, yes, 2 carbons. And
Mhm.
4, 5 electrons. 5 oxygen. Hmm. 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 Okay. So to balance this, you'll have to double it one more time.
Uh-huh.
Now count.
4 carbons, then we have 10 and 8.
All right, let's do one thing. Let's do one thing. I want you to separate this guy into ions. Now, usually you won't get a question like this, but to simplify for you, I'm going to give the answer for this one. Okay, it's not the usual one. It is usually how it works. So let's take it like this. Now, that's the equation we have. Okay. Now I want you to tell me what is the oxidizing agent and what is the reducing agent. From these half equations. This step is actually from what would you say? Extraction of iron. So I just wanted to show you this. They will not ask you a question like this. But if they give you half equations 2, 1 and 2, this and this, please tell me what is the oxidizing agent and reducing agent.
Iron is the oxidizing agent.
So therefore O2 minus is the reducing agent. Now that's enough for this one. Any questions?
No.